Definition of a function. A relation f from a set A to set B is said to be a function if every element of set A has one and only one image in set B. Okay, if you assume all the set of elements in the domain A being kids and set of all the elements in the codomain B be woman in the locality, then obviously every kid must have only one mother. And maybe some mother may not have kids, but every kid must have only one mother, not two mothers. Okay, so this is an example for a function. Okay, what is domain of the function? The set of kids. Here we can say the values of x. That's what we are going to input for the function. A function is a thing which converts one into other. Okay, how to find the domain when the domain is not given? Most of the time domain is given. Say a equals 1, 2, 3, 4, or a is set of positive real number, a between minus 3 and plus 3 both included. Sometimes it may be given like this, but if they say the function is on real numbers, find the domain, then keep in mind the denominator of a rational function. If the function is like p of x by q of x, that q of x is not at all equal to 0. And if the function is under the square root, and whatever inside the square root should be greater than 0. All those negative values inside the root is not at all real. So we have to avoid those things. Now let us see how to find range of function. Range is nothing but the set of values of f. Let us assume y equal to f of x. That means all those values of f of x, literally all the values of y is range of the function. So how do we find range? Let y equal to f of x and try to write x in terms of y. You know how to cross multiply whatever or squaring either side. Somehow you try to get x equal to something in terms of y. Say x equal to g of y is the thing what we got, suppose. Then use one of the condition like the denominator not equal to 0 and whatever the inside the square root is greater than 0. Using those conditions you can find the domain, but keep in mind for the restricted domain, according to the values of x, the y varies. So that affect the range. These two conditions won't apply there. And the next one, even though the function is on real numbers, given as y equal to some root of some function, root of p of y, something like that, then we keep in mind that square root function always have a positive values, even though that p of y in p of y is eligible to have some values in the negative also, but that cannot be taken into consideration because f of x is a square root function. Whenever f of x is equal to root of something comes, the output, the y value should always be positive, only positive real numbers. So it always a subset of positive real numbers. Let us see some examples. Suppose f is a function from R to R, both domain and codomain, the range is not given, but the function is from R to R, f of x equal to 2x minus 3. How to find the domain? Is there any denominator? No. F of x equal to 2x minus 3 has no denominator at all. Is there anything under the square root? Oh, nothing at all. Then x can take all the real numbers. So domain of the function is all real numbers. Okay, how to find range? Let y equal to f of x. Y equal to 2x minus 3. So y plus 3 equal to 2x. X equal to y plus 3 by 2. Is there any variable in the denominator? No, it's 2 is a constant. So it doesn't affect the value of y. Well, so y can take any value. So range of the function is all real numbers. Okay, in that example 2, f is a function from all real number to real number. F of x equals x square plus 3. So here no denominator, nothing under the square root. So domain can be any real number. So domain of the function is all real number. Now to find the range, let us assume as usual y equal to f of x. So y equal to x square plus 3, x square equal to y minus 3, x equal to root of y minus 3. So y minus 3 should be greater than 0. That means y is greater than 3. So y can take the values from 3 to infinity. 3 is included because 3 is y minus 3 not in the denominator. So range of the function is 3 comma infinity, 3 closed, infinity never be closed. Now let us see one rational function. Here the function is given as f of x equal to 2x minus 3 by 3x minus 2. We need to find the domain and range. Okay, here we have a denominator. A denominator shouldn't be 0, right? So 3x minus 2 not equal to 0. So 3x is not equal to 2. So x is not equal to 2 by 3. Thus the domain is nothing but all real number except 2 by 3. Now to find the range, we have to make the 2x minus 3 by 3x minus 2 equal to y, then cross multiplying. Then keep the things which contain x to the left hand side, all the other things to the right hand side. The thing doesn't have x to the right hand side. Now take x common, and we write x is equal to 3 minus 2y by 2 minus 3y. Well, when you look at the denominator, 2 minus 3y, that shouldn't be 0. So y 2 minus 3y not equal to 0. So 2 not equal to 3y, y not equal to 2 by 3. So the range is all real number except 2 by 3.